Good evening. This video is about the revision in the various concepts in heights and distances that you are learning right now. So there are two very fundamental things that we want to see here. One is angle of elevation and angle of depression. So what is angle of elevation? I am reading out the definition here. If you can see, the angle of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer eye. This is called line of sight. The line from the object to the observer, that is called line of sight. LOS. LOS. So we'll just see what does this mean. Let me just tell you the next one. Look at this diagram here. Where is the line of sight? We'll see line of sight here. So this is the object, this is the observer, and this is the horizontal line. So this line here is called the line of sight. Okay, so you should know what is line of sight. So again, let me tell you what is the definition of what is the angle of elevation. As you can see here, the angle of elevation of an object, I'm reading it out again. The angle of elevation of an object as seen by an observer is the angle between the horizontal from the line of sight. So it's, remember, it's always up. You have to look up in order to find angle of elevation. So this, you can see, it is looking up. So this one, as if you see it properly, then this is the horizontal and this is line of sight. So this is angle of elevation. So right now this is, say, any angle, alpha or theta, could be any angle, right? So next comes angle of depression. So I am reading it again. If the object is below the level, if the object is above, then it is elevation. If the object is below the level of the observer, then the angle between the horizontal and the observer's line of sight is called angle of depression, right? That is angle of depression. Let's see in the next slide. Look at this very carefully. This one is our horizontal line. This is our horizontal line, and he has to look below. So this angle beta is angle of depression. Okay, and next one, let's look at some solved example here to understand how it is being used in application of trigonometry. And here, if you see, I am reading it out here. The shadow of a building is 20 meter long when the angle of elevation of the sun is 60 degree. This is the 60 degree sun's altitude, sometimes also known as sun's altitude. Okay, this one, and this is the shadow length AC. This is the building AB. So AC is equal to 20 meter and angle ACB is 60 degree, as you can see here. Okay, and then how he has done the calculation, let's see. Yes, second, let AB be H. So he has written AB upon AC is equal to tan of 60 degree, as you can see this one. AB upon AC is tan of 60 degree. And what is tan 60? Tan 60 is root 3 from the trigonometric table. So we get H upon 20 is equal to root 3, as you can see this one. H upon 20 is root 3, and then H is equal to 20 into root 3, and this 20 into root 3 become 20 into 1.732, that is the value of root 3, and this is equal to 34.64 meter. So this is how you solve the very simple question in trigonometry. Okay, next question, I am reading it out. Look at this. If a vertical pole of 6 meter high has a shadow of 2 root 3 meter, so this is the vertical pole AB, and its shadow here is, say, this one AC. Okay, AC is equal to 2 root 3, as you can see here, and again we take tan of theta. This one, tan theta, is equal to AB upon AC, as you can see here, and the what is given, 6 meter height. So building AB is 6 and this is 2 root 3. So if you divide, then 6 by 2 is 3, 3 by root 3 is root 3. So root 3, whose tan is root 3, 60 degree. So the angle, this angle must be 60 degree. This is how you solve this question. Okay, next we have a very good question here, example number 6. and you have to read it, understand it properly. The question says a vertical tower stands on a horizontal plane. Okay, so the vertical tower stands on a horizontal plane and is surmounted by a flag staff. So on the top of the tower there is a flag staff, this one, okay, which is 7 meter. This BC is 7 meter, and at a point on the plane the angle of elevation of the bottom, this is very important that you understand the question properly. It says that at a point on the plane, so let O be the point on the plane, and then it says the angle of elevation of the bottom of the flagstaff, that is point B, and top of the flagstaff, that is point C, is 30 degree. So this angle is 30 here, and the bigger angle is 45 degree. And now we need to find the height of the tower, that is we need to find what is AB. Okay, so how is solved? We know that BC here, look at this BC is 7 meter, and AB we have taken as H, and then what we have done, we have to take different triangles. So he has taken OA upon AC. Normally we take AC upon OA and we write tan 45. He has written cot 45, but you should write tan 45 here. Tan 45 is 1, so OA is equal to AC. Now OA, this OA here, let me just go back. OA, this one, see again, this OA upon AC is equal to cot 45, so they are both equal. So he has written OA is equal to AC, and what is AC? AC is AB plus BC, so it is 7 plus H, this one 7 plus H. Okay, and similarly in the smaller triangle OBA, this one OBA, we can write tan 30 is written cot 30, but if you write tan 30, it is AB upon OA, so that is equal to let's see what is the value of that, the next one. So here you will see he has written this one as cot 30, you should write tan 30. Tan 30 is 1 upon root 3 and cot 30 is root 3. Okay, so you will again get OA upon H, the same thing here. OA upon H is root 3, so OA is equal to H root 3. This OA becomes H root 3, and now we also know that OA is equal to H plus 7. So H plus 7, this H plus 7 is equal to H root 3 here, and now we can solve this by taking 7 here and H root 3 minus H. So this H root 3, this I'll mark where is H root 3, this is H root 3 and this is H, so you take it that side, it becomes H root 3 minus H. So H is equal to, as you can see, H is equal to, it becomes 7 upon 1 minus root 3. Okay, something like that. If you, or root 3 minus 1, if you take it that side, root 3 minus 1. Remember, then he has rationalized it. As you can see, where is the rationalization? See here, this is called rationalization. So if you multiply by root 3 plus 1, root 3 minus 1, in the denominator becomes 2 after rationalization, and in the numerator it becomes 7 into root 3 plus 1. And on solving, root 3, you know the value is 1.732 plus 1 is equal to what? 2.732 multiplied by 7 and divided by 2. That gives us the final answer. And what is the final answer here? 9.562. So this is how you solve these questions on heights and distances. There are many more examples, and I'll be solving more questions for you in the next video. Okay, thank you for watching.